Everything you have ever seen, every star, every galaxy, every picture from our best telescopes, it all fits inside a bubble 93 billion light-years wide. That sounds huge, and it is. But here is the thing. That bubble is not the whole universe. It is just the part we can see, the part where light has had time to reach us since the universe began. Beyond that edge, there is more. Maybe a lot more. Maybe forevermore. But we cannot see it. We cannot touch it. We cannot send a signal to it. And we never, ever will. So what is out there? What lies beyond the edge of everything we know? The answer might be stranger than you think, because scientists do not just have one idea, they have several, and some of them will change the way you see your place in the cosmos. First, let us understand what we mean by the observable universe. The universe is about 14 billion years old. Light is the fastest thing there is. Nothing can travel faster. So the farthest we can see is the distance light has traveled since the universe began. You might think that means we can see 14 billion light years away. But the universe has been stretching this whole time. Space itself has been growing. So the light that started traveling toward us 14 billion years ago is now much farther away than where it started. The math works out to about 46 billion light years in every direction. Double that, and you get a ball of space 93 billion light years across. That is our observable universe. But here is the key. This is not a wall. There is no edge, no boundary. No sign that says, universe ends here. It is just a limit on what we can see, like being in the middle of the ocean. You can see to the horizon, but the ocean keeps going beyond it. You just cannot see that far. The observable universe is our horizon, and beyond it, the ocean of space almost certainly continues. So what is the simplest answer to what lies beyond? More of the same. Think about it. When we look in one direction, we see galaxies. When we look in the opposite direction, we see galaxies. When we look up, down, left, right, galaxies everywhere. The universe looks pretty much the same in every direction. Scientists call this the cosmological principle. It says the universe, on the biggest scales, is the same everywhere. No special places, no center, no edge where things suddenly change. If this is true, then beyond our horizon, there are probably just more galaxies, more stars, more planets, more of everything we already see. The universe might stretch on and on and on, with no end at all. This is the infinite universe idea. And it is both the simplest answer and, in some ways, the strangest. Because infinity is hard to imagine. It means the universe has no boundary. No matter how far you travel, there is always more ahead, forever. Before we go further, let us talk about what the universe actually looks like on the biggest scales. It is not just galaxies floating randomly in space. There is a pattern, a structure. Scientists call it the cosmic web. Imagine a giant sponge, or a three-dimensional spider web made of light. Galaxies gather along long strings called filaments, and these filaments connect at points where huge clusters of galaxies form. And between the filaments, enormous empty spaces called voids. Some voids are hundreds of millions of light years across, with almost nothing in them. This structure comes from gravity. In the early universe, matter was spread almost evenly, with tiny differences here and there. Over billions of years, gravity pulled matter toward the slightly denser spots. The dense spots got denser, the empty spots got emptier, and the cosmic web slowly formed. When we look beyond our observable universe, we expect this web to continue. More filaments, more voids, more clusters. The same pattern, stretching outward beyond what we can ever see. Here is where things get interesting. The universe might not be infinite. It might have a shape. When scientists measure the universe, and they ask, is space flat or is it curved? On Earth, we live on a curved surface, a sphere. If you walk in a straight line long enough, you end up back where you started. The surface is finite, but it has no edge. you never hit a wall. Could the universe be like that? Curved in a way that makes it finite but without edges? Our best measurements say space is very, very close to flat. Parallel lines stay parallel. Triangles have angles that add up to 180 degrees. All the usual rules of geometry work. But very close to flat is not the same as perfectly flat. There might be a tiny curve we cannot detect yet. If so, the universe could wrap around on itself in ways we cannot imagine. And this is where it gets really strange. Some scientists think the universe might be shaped like a donut. Not literally, of course. But imagine a video game screen where, if you go off the right side, you come back on the left. If you go off the top, you come back at the bottom. The screen is finite, but it loops back on itself. A three-dimensional version of this is called a torus, a donut shape. In a toroidal universe, space is flat everywhere you look, but it connects back to itself. If you flew in a straight line long enough, you would eventually return to where you started. You might even see yourself. Light could travel all the way around the universe and come back to you, showing you an image of the back of your own head, or more likely, an image of your galaxy from billions of years ago. Scientists have looked for this. They searched the cosmic microwave background, the oldest light in the universe, for repeating patterns that would prove space loops back. So far, they have not found clear evidence. But that does not mean it is impossible. The loop might just be bigger than the part we can see. Now let us go even further. What if our universe is not the only one? This is the multiverse idea, and it comes from a theory called eternal inflation. Here is how it works. Right after the Big Bang, the universe went through a period of super-fast expansion. Space grew faster than light, doubling in size again and again in tiny fractions of a second. This is called inflation. In some versions of this theory, inflation never completely stops. It ends in some places, like our universe, but keeps going in others. New bubbles form, each one a universe of its own, expanding and cooling, maybe forming galaxies and stars. In this picture, our observable universe is just one bubble in an endless foam. Other bubbles exist beyond our reach. They might have different laws of physics, different numbers of dimensions, different kinds of particles. Some might not be able to support life at all. Others might have forms of life we cannot imagine. We cannot see these other universes. We cannot communicate with them. The space between bubbles is expanding so fast that no signal could ever cross it. They are forever beyond our reach. But wait, if other bubbles exist, could they leave a mark? Some scientists think so. If two bubble universes formed close together, they might have bumped into each other before drifting apart. That collision would leave a bruise, a circular pattern in the cosmic microwave background. Teams of researchers have actually searched for these bruises. They looked at data from space telescopes like WMAP and Planck, and hunting for the telltale circles. So far, they have not found clear evidence. The data does not require bubble collisions to explain what we see, but the search continues. Future telescopes with sharper vision might find something the older ones missed. Imagine that. A scar on the oldest light in the universe, left by a collision with another universe. Evidence that we are not alone, not just in our cosmos, but in the multiverse. Here is the hard truth. We may never know what lies beyond. The cosmic horizon is not something we can cross. It is not a physical barrier. It is a limit set by the speed of light and the age of the universe. And it is getting worse. The universe is expanding, and that expansion is speeding up. Galaxies are moving away from us faster and faster. The farther away they are, the faster they go. Right now, there are galaxies so far away that the space between us is stretching faster than light can travel through it. Light from those galaxies will never reach us. They are already beyond our horizon, slipping away forever. As time passes, more and more galaxies will cross this line. In the far future, trillions of years from now, the night sky will go dark. Every galaxy outside our local group will have faded from view. Future beings will look up and see only the stars of their own galaxy. they will have no way to know the universe was ever bigger. So why think about this at all? If we can never see beyond the horizon, why does it matter? Because it changes how we understand our place in everything. If the universe is infinite, then somewhere out there, impossibly far away, there might be another Earth, another you. In an infinite universe with random arrangements of matter, everything that can happen will happen, somewhere. Your exact life, your exact thoughts, playing out again on some distant world. If the multiverse is real, then our laws of physics are not the only way things could be. They are one possibility among countless others. We live in a universe that happens to allow stars and planets and life. Other universes might not be so lucky, or they might be luckier in ways we cannot imagine. Either way, the question of what lies beyond forces us to think about the nature of existence itself. What does it mean for something to be real if we can never see it, touch it, or prove it exists? These are not just science questions. They are philosophy questions. They are the biggest questions we can ask. Here is what we actually know. We know the observable universe is 93 billion light-years across. We know it contains about 2 trillion galaxies, each with hundreds of billions of stars. We know it is organized into a cosmic web of filaments and voids. We know space appears flat, at least as far as we can measure. We know the universe is expanding, and that expansion is speeding up. But beyond our horizon, we do not know. Maybe it is more of the same, an infinite ocean of galaxies. Maybe it wraps around in ways we cannot picture. Maybe it is one bubble in a foam of universes. Maybe it is something we have not even thought of yet. And maybe that is okay. Science is not just about answers. It is about learning to ask better questions. The question, what lies beyond, has driven humans since we first looked up at the sky. We asked it about the horizon of the sea, and then the edge of the world, then the limits of our solar system, then the boundaries of our galaxy. Each time, the answer was more. More than we expected, more than we could see. Tonight, when you look at the stars, you are seeing light that has traveled for years, sometimes for thousands or millions of years, to reach your eyes. But there is light that will never reach you. Stars that have already burned out before their light could arrive. Galaxies that are speeding away too fast to ever be seen. And beyond all of that, beyond the farthest light, beyond the oldest glow from the Big Bang, beyond the edge of everything we can observe, there is more. We do not know what. We may never know, but it is there. The universe is not just bigger than we can see. It is bigger than we can imagine. And somehow, against all odds, you are here, alive, and aware, able to wonder about it. That might be the most amazing thing of all. You are a tiny piece of the cosmos that woke up and started asking questions about itself. And the biggest question, what lies beyond, may never have an answer. But that will not stop us from asking.